Um, 1 and 2, they've given you the picture, so I just want you to be able to read it off the picture and focus on the correct scale. So like, let me get my pen. Since this ray, the vertex M, and this ray points to the right, this is the 0 scale right here. So we have to use the inside. But I can physically see that this is, oops, sorry. This is an obtuse angle. So I cannot pick like a small number less than 90. I got to pick a number greater than that. So if I use the inner scale here, this should be 120. On number 2, vertex is here. Again, it's pointing to the 0 scale. Use the inner. This is in between. It looks like 40 and 50. So halfway in between would be 45. So here, this is when you have to use your protractor. The methods can vary, but the thing that cannot vary is lining it up. So let me make this a little smaller. When you line this up, you have to line up with the vertex, and then you have to do your 0 line. Okay, I need to slide this down some. Oops. Okay, so you want to go through that 0 line. There we go. And then you read the other ray. This one, I would take either, this is the inner scale here. I would take 110 or 111 because it's kind of in between. Okay, this is obtuse. You have to get measures that match the size of the angle. Like this angle I can physically see is acute. So again, make sure you can line up the vertex with the 0 line. Let me get, come on, it's not working, hold on. There we go, there we go. I gotta bring this up. We'll take, let's go through the 0. All right, so this is actually past 70. This was 72. All right, then we needed to draw. Make sure you sketch your MB. On some of the papers that passed back with your grade, some of the points are off because you didn't follow the directions. So just watch that you actually put this ray MB. We need to add the B. We want this to be 65 degrees. So let me get my vertex lined up with M. Sorry. And then, oops, go through the 0 line. 65 is between 60 and 70. I just need a tick mark right there. Okay. So I have my tick mark, and if I just use my edge, it should let me use the edge. We'll see. Actually, let me not do that. Basically, the ray needs to go from the M to that tick mark. And we need to add that point as B. Okay. This one's acute, the other one's obtuse. All right. So on your test, you will have to use a protractor. Measuring and drawing, constructing an angle. Basically like the last 4. Okay. All right. So go to the next page. Okay. 7 and 8 are these pages here. This correlates with the doodle notes where we had to name and classify angles. And then this is also part of the yellow foldable. Okay, so I'm just going to go over a couple in each section to make sure you're on the right track. The name is given here. It is angle 1, so I see 1 is in the interior. So the angle I should be focusing on is with the angle with these 2 sides, the ray X, RI, excuse me, and RC. So I name now, if I'm using the number, then now I'm naming it with the 3 points. This angle should be IRC, or I could say CRI. The thing that's important is the vertex. The vertex should be always the letter in the middle when we're using 3 letters. Okay, so number 8 is just like number 7. Now, When we get down to number 9, I want to circle 9 and 10. These are the test-like. So you're going to be given the diagram, asked to draw on the diagram or to label. This one says use a straight edge to draw ray AR. I'm going to use a ruler, guys, because my protractor on my board doesn't work so well. So what we have to do is line up my straight edge from the A up to the point R, because we want to draw a line through them. So we're going to draw a line going from A to R. My line is just slightly off. Let me fix this just a little bit. There it goes. Okay, so now I have this ray right here, and it says name the pair of adjacent angles. So you have to know adjacent angles. That goes back to that yellow foldable. These are angles that share a vertex, so it has to share A, and it shares the side. That's the ray we just drew. So one of your angles is from this ray. Okay. I can name that angle. Let me delete that. This is angle using 3 letters. This would be angle FAR. Okay. The adjacent angle is right next to it, sharing the ray side. Oops, I should have just done a different color right here. So here and then here. Okay. So I can say angle RAB, or you can say RAY, far ray. Okay. So because I'm going to give you the diagram and it's going to have several lines, make sure, this is why sometimes highlighting helps you focus on the right part. They want you to find adjacent, this is key information, adjacent to angle FGJ. So I'm just tracing those letters F to G and G to J. So the angle is this obtuse angle there. So, oops, sorry, let me fix that. So there are 2 possible adjacents. Adjacent means it shares a vertex and a side. Since I already know I'm using the vertex G because that was given to us, now I need to pick a side. I can pick the side here, which is GR. So name the angle adjacent using that side. No, not FGE. FGD, yes. I could use, I'm just going to put a number there. Let me get rid of this part. So when I'm saying FGD, okay, that's one of the adjacent angles to the obtuse that I highlighted. That's using the side FG, or I could use this side over here. So what angle would it would be HGJ, yes. So you have to be able to read it off the diagram. This is the second angle, okay? All right. Now, number 11 through 13 are all dealing with bisectors. It says right here, LM is the bisector. You need to know that that's going to create 2 congruent angles. This is on the yellow foldable as well. So if I tell you every one of these LM is the bisector, I don't care if it doesn't look like it's to scale, then that ray is cutting in half and it's making 2 congruent angles. So arc and arc to show angle bisector. Arc and arc. They did the arcs on number 13. So 11 here. If I give you this 26, I can see that that goes with JLM. That's the first blank. So if that's 26, the angle adjacent to that, MLN, what is its measure? It's 26 as well. Good. So now we want to find the whole angle, which is JLN. That's the whole thing. 52. Yep, 52. We just add them together. Okay. So on 12, I don't give you the measure, but I do give you this box right here, which is important. It's 90. So to find each angle, yep, you just take half of that, which means it's 45 and 45. Do we have that down? All right, so on 13, this 150 is for angle JLM. So MLN is also 150, and I know this is not to scale, meaning it doesn't match its actual measure. Okay. So if I add each part, the total would be 300. That's what I'm talking about. It's not to scale. All right, next page. Okay, we're gonna need to talk about this. From this part on, basically, we're using the pink the pink graphic organizer. So you need to use your pink. This is the page you were supposed to do yesterday. Okay. All right, you can highlight to focus on the angles. This first one, we want us to focus on angle 1. That is this ray is the side, and that ray is the side. And I'm going to compare 1 and 2 together. So that would be this is the side, and that's the side. There's my 2 angles. So they want to know the type of angles that are formed. That's one of the 5 types that are on the pink paper. So you might want to refer to the pink paper, the one you did yesterday, right? Everyone with me on talking about? So what does angle 1 and 2 look like off that paper? A linear pair. We're going to write linear pair. You can put LP. Yes, that's an easy shortcut. And then it says, so they are. What's the relationship of linear pairs? Yep, they are supplementary, which means equals 180. They have a sum of 180. So 1 and 2 is an example of a linear pair. Well, now they want you to focus on 2. So here's my sides to 2. And 3. Here are the sides to 3. The key to it, guys, if it's a linear pair, the word line is in linear. The angle should form a line. Every line has a sum or a measure of 180. So if they fit on the line, okay, then they are a linear pair because they're adjacent and they're supplementary. So this also was a linear pair. And they are supplementary. Now, one of the new angles that they refer to on the pink notes, if I'm comparing angle 1 and 3, okay? What would these angles be? Yeah, vertical. They are across from each other, okay? So these are vertical angles, which means angle 1 is blank to angle 2. What's the relationship? They're congruent. I'm just going to put the symbol. Vertical angles are congruent. We got this? Okay, so you are going to have vocabulary just reading it off a diagram, but then I'm going to ask you to problem solve using those 5 types of angles. Okay, so I'm going to give you the steps here. You might want to write them down. If I ask you to find an angle measure, you need to always first use vertical. So first, do the vertical angles. Because your vertical angles are congruent, are equal. So there's no math to that one. After you do your vertical, then you're going to do supplementary or linear pair, okay, or LP, because they're going to have a sum of 180. So I look on the diagram here on number 17. We start off, they give me the angle 42 degrees. Is that vertical to any angle? To which angle? Yes, so that means angle 2 is also 42. It's congruent. Vertical angles are going to have the same measure. All right, now that I did the vertical, now I got to do supplementary. So I go to angle 1 here. I do 180 minus the 42. This is 138. And it is vertical to angle 3, so it would also be 138. So start with vertical. Do I have a measure that's vertical to an angle? Look at 18. Do you have an angle measure that's vertical to another angle?
85 and 2.
Yeah, 85 and 2. So that means 2 is also 85. There's our vertical. Okay. Now that we've done vertical, now we're going to do a linear pair or supplementary. Huh? 1 and 3 are vertical, but they're supplement to 2. So to get 1, I'm just going to do 180 minus 85, which is 95, which means 3 is also 95. So 1 and 3 are vertical, and they would have the same measure. All right, so now let's talk about how to get to angle 4. Angle 4 is this angle, but it's adjacent right here on this line. You see this 154? To find that angle 4, I'm doing 180 minus that 154. So this would give me 26. So what would I have to do for angle 5? Because there's another line right here. Yep, 180 minus the 59. Good. 121. There we go. All right. Okay, so you're definitely going to have to find missing angle measures using vertical and linear pairs. All right, now I want to talk about the next page, because now we're going to go from just computation, adding or subtracting, to now algebraic relationships. So this also goes with your yellow foldable. We talk about your yellow foldable and your mixed practice. When you're studying and looking over things, you need to look at that yellow photo of mixed practice. So this first one, I'm going to go over is 21 here. What you do is you take the given information and you label it. It says right here, the measure of angle JKL. So if I just go from J to K to L, that represents the whole angle, which is 70. The whole angle is 70. And then they give us 2 adjacent parts. The part JKM, they're telling us it's this expression x plus 31 right there. And then our part MKL is this 4x plus 9. If I have the whole measure of the angle, then this is going to require part plus part equals whole. So the parts that we have are this x plus, I'm gonna come down here. Oops, sorry, go forward. It's the x plus 31. That's the first part. Plus the 4x plus 9. It's gonna equal the whole angle, which was 70. Write that down, because what I'm gonna check off is you'll get points for labeling and then points for setting it up correctly. So to solve this, you're gonna need to combine like terms. So that gives me a total of 5x's plus 40 equals 70. Yeah. We need to solve for x, so minus the 40. 5x equals 30, which means x is going to be what? 6. Okay, so if x is 6, is that our answer? Yeah, you got to plug it back in. We're plugging it back in right here where it says MKL. That means what I'm doing basically is saying 4 times 6, because that's what x is, plus 9. 24 plus 9 gives me 33. Okay. So this problem is dealing with adjacent angles. just going to put adjacent angles. If I see adjacent angles, we need to do part plus part equals whole. Okay? Now, when you go to 22, now the key word is bisects. MO bisects the angle. So if I just highlight that bisector right here, here's M to O. It's bisecting the whole angle PMN. It's cutting it in half. To show a bisector, this is when we put an arc and an arc. So we want to write this down, and then it tells us right here, PMN, that was the whole angle, is 74. The next thing it says, the measure of angle OMN, that's this, I'm going to just draw an arrow pointing to this angle here. That's the 2x plus 7. So, because we have a bisector, we're either going to have two congruent parts or double the part equals the whole. We have to double, yes, because since we have the whole, that means we have to do 2 times the part equals the whole angle. We're going to double the 2x plus 7 and make it equal the 74. So you have to distribute the 2. So really this is 4x plus 14 equals 74. This one they want you just to solve for x. So when I subtract the 14, I get 4x equals 60. And then we just divide by 4. So x is 15, and we're done. Now, on 23, the key information is this upside down T. What is that indicating? Right angles, perpendicular. So we need to add the box. Here's my BD right here. Here's my AC. So I need to put a box to show 90 degrees. Then if I look, they tell me the measure of angle DBE. So D to B to E. Inside of this angle is the 2x minus 1. I'm just going to label that part. And then CBE, C to B to E, inside this angle is 5x minus 42. What do we know about these angles? What are they? They're adjacent, and there's something else. What would their sum be? 90, yes. If they're complementary, yeah. If it's 90 here, then it's 90 on the other side. So all I have to do to write my equation is to add them together, the 2x minus 1 plus the 5x minus 42 equals 90. So now to solve, we're doing combining like terms. You need to combine like terms. So our like terms are the x's here, that's 7x. And then our minus, so minus 43 equals 90. Add 43 to both sides. I'm going to come up here because I'm running out of room. So 7x equals 133. And now, yep, now we're just dividing. Okay, so you will have a couple like this page where you have to write an equation and then solve for x or solve for the variable. Now, was everyone here? Yeah. On this next page, okay, go to the last page with me real quick. The first part is knowing your vocab. So on this section, complementary, these are ones that equal 90, so we're looking for a box. Linear pair, they equal 180, so we're looking for a straight line. Sorry about that. Okay. Vertical, these are across each other. Adjacent, these are next to each other. Okay, and then supplementary, these just equal 180. Those are the 5 that are in the pink. Hold on just a second. If you look here, A is this angle here with this ray, and B is over here. But they gave you a clue, this box. So there can be more than one name here. What type of angles do you see here? Adjacent and complementary. I'm going to abbreviate both of those. Yep. Because they're next to each other and they have a sum of 90. All right, so now on number 27 here, I have my angle A is just these 2 rays, and my angle B is right next to it. So what do you think these are? Yeah, these are adjacent. Notice that, oops, sorry. I'm just going to abbreviate that. Notice that this is extra. They're just trying to give you a line to throw you off. Just focus on the angles. All right, what about 28? Yeah, these are vertical. They're across from each other. So they would end up being congruent. What about 29? Yeah, just adjacent. Okay. They gave you an extra line because this is angle B here. And then here's angle A. So this over here is extra. Okay. They're just trying to throw you off. All right, now name it and find the missing angle. So what type of angles are shown here with this 70 and this angle B? Adjacent, and what else? They are supplementary. They're a linear pair. LP, a linear pair. So to find B, because they're supplementary or a linear pair, you just have to do 180 minus 70. Yep, 110. Now, for 31, because they gave me this box right here, that's very important. And these angles are adjacent, or basically in that box. These are complementary angles. That means they equal 90. So B is just a 90 minus 48. And then 32, what do you think these 2 angles are? They're vertical, so what is B? 50. They are congruent. They equal the same if they're vertical. So now we're going to mix it all together. So if you look, the last thing I'm going to ask you to do with those special types of angles is find missing angle pairs. So always start off with label the angles. The measure of angle 1 is 35. So here's angle 1, put the 35 right here where angle 1 is. And then angle 3 is 125. So put 125 right here with angle 3. 10 is 90. If you notice, they already put the box there. Okay, so we already know that's 90. And then 112 is 40. What should we label first? Which one should we do first that are the easiest ones? Vertical. Okay, who's vertical to this 35? 6. So put a 35 right there. 8, 125. 10 is 13. Put that box. 11, 40. There we go. Now, do your linear pair, your supplementary. So start with 1. Who supplements? Right there is 2 because they're on this line right here. So to get angle 2, 180 minus 35. 145. And then who's vertical to angle 2? So that is also 145. Now let's try angle 4. Okay. How we get to 55? Yeah, 180 minus the 125. Yeah, 55. And who's vertical? 7. There we go, 55. All right, now angle 11 and 14, these are not linear pair. These are complementary. So to get 14, guys, you have to do 90 minus the 40. So this would be 50. And who's vertical to that? 9. And this is 50. Okay, so that's what you have to do on the last one. If you're done, yeah, you can. Unless you want to keep it for studying. Make sure, guys, you finish. And this is what you do. You study.